Let's quickly review the main concepts here. In this section, we're looking at where the function is increasing or decreasing, and then where the function is concave up or concave down. And what I really want you to keep in mind is that for increasing, decreasing, you look at in all of your work is with your first derivative. So you set your first derivative equal to 0 or does not exist. And then you draw a number line, and the number line that you draw is about your first derivative. You plug into your first derivative, and when your first derivative is positive, that is telling you that the function is increasing on that interval. And if the first derivative is negative, then that is telling you that the function is decreasing on that interval. So all of the increasing, decreasing is about the first derivative. But the second thing that I really want you to understand is that this process of set the derivative equal to 0 or does not exist, plug into the derivative, that is the same exact process that happens over here for concave up and concave down. It's just now we are doing it with the second derivative. So we're going to set the second derivative equal to 0 or the second derivative does not exist, and then we'll plug in those numbers. And if we have a positive when we plug into the second derivative, so again, we're plugging into the second derivative, and if we have a positive, that will tell us that the function is concave up, CU, on that interval. And if for some reason we get a negative when we plug into the derivative, that tells us our function is concave down on that interval. But it's really important, like when you look at these two different processes, the first derivative is going to be increasing, decreasing. The second derivative is going to be concave up, concave down. But the process is the same. You're taking the derivative, you're setting it equal to 0, or you're taking the respective derivative, does not exist. And remember that that really amounts to where is the numerator equal to 0, where is the denominator equal to 0. Okay, and then once you do that, then the second thing is you draw your number line. And that number line that you draw, again, you might be plugging into the first derivative, you might be plugging into the second derivative, but when you draw the number line, you're plugging into the derivative. So I always think about draw and derivative. So when I plug in for the number line, when I draw my number line, I am plugging into the derivative. Now, for some of these questions, we want to find the point. So we might want to find like the point of inflection or the point for the extrema. And the point is the point that you've always known. It's x comma y. And so when you're trying to find a point on the graph, you are going to plug into, to get your y value, you are going to plug into f of x. So when you're asked to find the point, that's when you're going to plug into f of x. But drawing the number line is always going to be about the derivative. So drawing the number line, we plug into the respective derivative. Okay, and then keep in mind that if you have a change in concavity and you also have the tangent line existing, then you will have a point of inflection. So there is going to be some concern about, do we have a point of inflection or an inflection point? And just as a reminder, that happens when f prime exists. So we have a tangent line. And the second thing is that f double prime changes signs. And that will give us our point of inflection, which will be an x comma y value.